Hey guys, my name is Ivan. I work as a front-end developer here at Data Art Wrocław. And today we are going to be talking about Angular2. What is it? We'll quickly review the Typescript and then discover the Angular2 ecosystem. And shortly we will take a look at the architectural approach of building Angular2 applications. So, first of all, Angular2. First of all, it's a JavaScript framework for building single-page application. And by the way, how many of you guys have experience with the first Angular? Nice. So you already know a lot of principles of single-page applications and services, providers, directives, right? That's pretty much similar. It has improved dependency injection framework and the new change detection. So basically no more digest cycles. It has basically all you need to build a complex web application, from routing, templating, form builders, HTTP modules, but it's pretty similar what we have in the first Angular. Currently, it's in RC5. Around 2 weeks ago, they released RC5 with some big changes in there. We'll take a look at that. And next feature would be server-side rendering. So it comes with a full solution for universal rendering. You can get more information on the official website. It basically means that you can you can generate your HTML web page on the server side, and just when you press F5, you'll see the complete web page without all that loading stuff. Also, it's really good for SEO stuff, and when you are sharing your web page in some social networks like Facebook or Twitter, you won't see that ugly curly braces. It will be just normal web page. Lazy loading. So Angular2 router comes with the support of lazy loading the code of the route only when you are first access that route. That's actually the feature that we lacked in the first Angular. Native app support. Hey, native app support. You can build a native mobile iOS or Android application with Angular2 with the native script. It actually compiles to the native code, and you can also build some desktop application with Angular2 and Electron. And of course, web workers. You can configure your Angular2 application so most of your code will run on a web worker. It's kind of a separate thread, so which is cool. Yeah, and let's quickly take a look what's the TypeScript. So the language we usually call JavaScript is formally known as a ECMAScript. ES5 was the 5th edition, and it was standardized in 2009, and it's mostly implemented in all modern browsers. Last year we had an ES6. It was standardized in 2015, so ES 2015. This version came with a lot of cool features like arrow function, classes, modules, spread operators. And by the way, does any of you guys use ES 2015 on your real projects? That's really nice. Yeah. And there's already a proposal for ES7 or ES 2016 and the TypeScript, which is actually not a separate language. It's just a superset of a JavaScript. It has all the features of JavaScript with some optional typings, I would say. We have a list of types here and the tools, but we have an example of that. Is it fine? Like the font? No? Okay. So we have a function here that can add two numbers, and when we try to do that with numbers, it will work fine. But if the first parameter would be a string, then we won't receive a result that we expected. So how can TypeScript help us with that? Let's copy that file and just rename it. So let's make it TypeScript, and that's it. It's already a TypeScript. As I said, it's a normal JavaScript, but with the additional and optional typing. So if we make this the first parameter type of number and the second parameter number as well, then you can see that TypeScript throws an error which says that the string you are trying to put a string which is not a number. It's a really cool feature. It can save us time while development and refactoring. Let's see some other types in TypeScript. So we have boolean there, we have a number, we have a string, we have an array, but usually it is array of something. So in this case, it's just an array of numbers, like that. And one more thing here, if you're not sure what type to use, or maybe you will change your variable, then you can just put any, and that's it. There is also a custom type in TypeScript. You can apply a newly created class as a custom types, but TypeScript has its own new feature which is called interface. It will not produce any of code ES5, ES6. It's just for the TypeScript compiler to, or maybe even for you to know what type to use. Let's create an interface user, for example. Usually interface are named with the I at the beginning. It's kind of a convention. Let's try to do that. So our user should have an ID, which should be a number, and let's say a name, which can be a string. So now when you create a new object, let's say we are creating a user which should be a type of user. TypeScript will throw an error that it will just say that you don't have the ID, and you also lack a property name is missing. That's it. And for example, here we have an object of similar users. We can also specify that this is actually a array of our types, or we can have a class which can be a service that has a method get users, and it should return the same, an array of such objects. Yeah. When you create an instance of that class, you will see that and trying actually to call that method, you will see that TypeScript compiler actually tells you that it is an array of user objects, and when you try to do something with that, it will give you only method of only array methods, because it's actually an array. Or even when you try to access any of the item in that array, it knows that it is an array of users and there should be such properties, ID and name. So which is cool. You can also have an interface for your function. Interface. Let's name it callback. So basically, if you have a function and you're expecting a function as a parameter, which can be a callback. Let's make it in a node style. So first of all, should be an error and some data, which can be any as well. And this function just does nothing. So and now when somebody is using a function then incorrectly, then he'll just receive an error message that it should be a function here. That's enough to start with the Angular 2. So let's continue with our presentation. So Angular 2 ecosystem. First of all, we have a component in Angular 2. Angular 2 is actually all about components. The whole application can be modeled as a tree of these components. This is how it looks like. I actually have a plunker here. This is the simplest component written in Angular 2. So first of all, you will need to import a component function from Angular core. Then you will create an empty class and decorate that class with the component function with several properties. At least a selector, which is how you can get your component, and a template. That's it. That is how it works. Of course, you can move your template into a separate file. It will look like that. But we don't have that file, unfortunately. And let's quickly take a look how we can style our component. There are at least two ways to style it. Write that inline. Let's make our h1 element red. And you can also move all your styles into a separate file. But a nice feature with styling here is that all the component styles will be applied only to your particular component. So we will style only our h1 element, not all the elements in the application. Yeah. Styling and the life cycle. So every component has a life cycle managed by Angular itself. Angular creates it. Let me actually show that. Angular creates it, creates that component, renders it. It's happened on init. Creates and renders its children. It can also check when its data-bound property change in geon change, and of course destroys it before removing it from the DOM. Let's quickly take a look how we can use those functions. We need just to import those functions from the Angular core and just using them. We will have an example with one of the methods, so we'll take a look. Let's continue with the module. This is a new feature. It was introduced in the latest release candidate about 2 weeks ago. So kind of everything was changed. ng module and bootstrapping. Let's take a look. So every component should be a part of a module, and every application requires at least one module. But it's similar what we have in the first Angular. Many Angular applications are separate modules, and many third-party it's like in the first Angular. You find something, you download it, you include it into your root module, and you can just use those directives. And let's quickly take a look how we can actually run the application. To do that, we will need a function which is platform browser dynamic, which can bootstrap your module. We're using this function because bootstrapping is platform specific, and you may load your module in different environments. Like, as I said, it can be a mobile application or somewhere in the server. And of course, it's better to have a separate file for that process, at least for separation of concerns. And of course, a service. As most of you guys have a background in Angular 1, you are familiar with the concept, but in Angular 2 it's much simpler. There is no service/factory. In Angular 2 we have only services, and they are just vanilla ES6 classes, like that. But to make those injectable into other services, we have to decorate that class with the injectable function. And let's actually take a look at the example. If we have one. So here we have a separate service which has it's just a class with one method, get users, and you can inject it on the module level. Here it will make available that service throughout the whole module, or it can be done on the component level. First of all, we need to import from a and exactly the same that's it. This one line will make your service available throughout your component and to its child or children, of course. Okay. There are much more stuff to check, but I'd like to get back to the components and quickly take a look at the way of building application from architectural perspective. So let's take a look at the component architecture. If you ever learned React, then you've probably seen this article, Thinking in React. But actually step 1 can be applied not only to React. It's actually a short explanation of a component architecture, which says that your Angular, your application should be a tree of small components. Let's have an example. We would like to build an application that has a list of users, a search, and small information of a selected user. Now we need to split all those features into separate components, like this. We have a root component, which is app component, and we have its children, search, user list, and user edit. During development, you will probably notice that, for example, user edit, it's not really enough to have this only component. So you will probably want to create some more components like that. But those components have blue background because they are so-called stateless components. They basically don't know how to read or write data. they receive data via property bindings and just output some data via events. And those white components are container or stateful or smart components, because they actually knows how to read data, write data, they communicate with the services and stuff. And Angular2 change detection enforces unidirectional data flow. It runs and updates the view when the data on our classes gets updated. Here we have our components tree, and for example, in Angular1, we have two-way data binding by default, which means that anything could change anything else, which makes a little bit chaotic that flow. And in Angular2, the flow of information is unidirectional. As I said, this is our tree of components, and user edit has user edit image and separate component for the info. And so this component will receive some data via the input and gives a response via the output using event. We have a demo, small. Let me just run the application and we'll see. So this is similar to that application. Let's take a look at the main module. So we are importing some modules. It can be third-party libraries or your own modules, but your root module has to have a browser module. It's from Angular platform browser, and it will include to your application some services and directives like ngIf, ng4, and we'll need a form module because we'll have a small form there. Inside declaration, this is actually the place where we make our Angular application know about all the components and pipes that are used in our application. And the bootstrap. Here we have to specify the root component of our application. As you can see, we have three components. Root component, user list, and user edit. Let's quickly take a look at the app component, the root one. Here we inject a user service, which is really simple. Where is it? Here it is. It will just return an array of user objects. Everything is static, so yeah. This is how we include that service. Let's take a look at the template. So it's a little bit styling with a Twitter bootstrap, and let's command those user list and user edit. So dependency injection is happening in the constructor. You have to specify you have to create a private variable here, which will be, for example, user service, and it's using the imported user service. This will make this .user service available through your class. This is how we can use it. We are using ng-on-init function to fetch all users at the beginning of when your application is actually created. So fetch users will actually fill these users, and at the beginning we should have, let's say, we have 3 users. But let's implement a list of our users. We have a separate component for that, which is called user list. It has some inputs and outputs. So, as a input, we receive a user array, users. We also need a selected user, because we will have to highlight the selected user. And as a output, we will have one method on select, which will just tell your parent that one user or one item was selected. This is how it works. We pass those users array to our user list component. We pass selected user as well, if it is already defined. And onSelect method will call the onUserSelect from our app component class. OnUserSelect will just receive that value from the child component and put that into selected user. So, for example, we can put like into our parent component selected user. Okay, so this child actually can tell its parent that one user was selected and pass that object into that parent. Then we create a new component, userEdit, pass the selected user into there, and it can do something as well. In our case, it will save on userEdit, like that. So kind of a unidirectional data flow. So when your component receives something and outputs it as an event. That's it about the unidirectional data flow. There is one more tool to mention here, which is Angular CLI. You may get more information on their official website, but unfortunately it is not updated to the latest RC5. So using this command line interface, you can actually create a project from scratch, components, directives, services, lint your code, serve it, but for now it's not updated, so it is without modules, and bootstrapping is a little bit different, so I will not show it to you right now. But I would also like to talk just a little bit about components in the first Angular, because we have directives there, and Angular 1.5 introduced a new method, which is component, which is actually a special kind of directive that uses similar configuration. And this actually makes it easier to use Angular 2 styles of application, and this is actually from the Angular's website, that it's really similar that we have in Angular 2, that component have a well-defined public APIs. There should be inputs and outputs. Inputs should be where is it? Inputs should be using this one-way data binding, and outputs are realized with the method bindings. Components also have a life cycle, and application should be built as a tree of components, and of course minimize a two-way data binding. That's all. I actually have an example of a Angular 1.5 application with the ES6, so if you are interested in that, I can show you after the presentation. That's it. Thank you. we have a question.
Yeah, so I have just a brief question. It's more regarding TypeScript than the Angular 2, but anyway, as far as I know, TypeScript was developed by, I think, Microsoft some time
That's
ago.
right.
Yeah, and I was just curious if that's sort of a language that is being compiled after that into JavaScript, or uh, it's something more complicated, or it's just sort of a separate language.
No, no, no. As I said, it's not a separate language.
Mhm.
It is all the types are optional. So you may kind of use a TypeScript, but write your own, like normal JavaScript. I mean, normal JavaScript by
Plain JavaScript.
yeah, plain JavaScript ES6. So
Uh-huh.
it has all the features is of ES6 and ES7 and those optional types. That's and
Got it.
you're right. It was developed by Microsoft.
Yeah, so in this case, you can actually take either CoffeeScript or plain JavaScript or TypeScript or anything else.
Actually, you can write Angular2 application with TypeScript or normal JavaScript or even Dart, but
Mm-hmm.
who needs that? But Angular2 was written in TypeScript, and it's recommended to use TypeScript with your Angular2 applications.
Got it. Yeah, that's exactly what I wanted to hear. Thank you.
No problem.
Basically, from this presentation, which we have already seen, it looks like this Angular 2 went in such a direction that that this is very close to React.
That's
And
right.
well, the question is if it is going, let's say, more like React, and for instance, what it used, let's say, while rendering or before the rendering to check if this component should be rendered. For instance, if it is in same way as in React that it uses virtual DOM or something else.
Yeah, actually, it's pretty similar because it has the same unidirectional data flow. And actually, as I said, the change detection needs that unidirectional data flow because it will, in Angular 1, we had that digest and anything could happen. I mean, your child component could have been changed before your parent component. In this case, in Angular 2, we have unidirectional data flow, and this change detection goes from parent to the child. It's similar what we have in React. We will have next presentation about the React. You will know what's happening in there. So I would say like that. Is it an answer to your question? Okay. Thank you.
No, cześć wszystkim. Bardzo dziękuję, że jesteście tutaj dzisiaj z nami i bardzo miło, że jest was tutaj aż tak dużo. No to będziemy zaczynać. Dobrze. But before we start, I would like to make one small thing. Hi, Mom. So I just wanted to say I love you. That's because we are live here, so she's probably watching it right now. Okay, so we can start. Today we're going to talk about React a lot. But at first, let me introduce myself. My name is Kirill, and I work as a JavaScript developer here at Tate, which you've probably heard about. Okay, so what is React? At first, let's have a look at our agenda. I'll tell you about what is React and why would you consider using it. After that, we'll recap our knowledge about basic rendering of the layout in the browser. Then I'll tell you how React renders elements and how to make React to work even faster. Okay, so what is React? I'm almost sure that you've heard of it before because it's extremely popular right now. I mean that every developer wants to know how to use it, every client wants to have a project which is built in React, and every girl dreams to meet a guy who knows how to code in React, right? Yeah, okay, of course I'm kidding because clients don't care about technology, they only care about making money from their project, and that's it. So, okay, so what is React? React is a JavaScript library for creating user interfaces. It is developed by Facebook, but it's open source, it's available on GitHub, and you can check it out anytime you wish. So if you're familiar with other frameworks like Angular or Ember or Backbone or 1,000 others, I don't know, you might hear the abbreviature MVC. And please notice that React is just a V in MVC. It means that it is designed only for rendering your layout. And it means that, unfortunately, you cannot build a fully functional dynamic application with React itself. You might need some additional stuff for routing, for processing your model, and so on. But there are a lot of good practices, best practices, which are used, so don't worry about it. Also, there is a thing that React introduces. It's a specific syntax, which is called the JSX. It's kind of a combination of JavaScript and HTML. It might sound weird at first, but actually it's not really difficult stuff to learn how to use it. Okay, so why would I want to use React, right? In React, it's all about components. Well, you've heard about components before in Angular2, but React is also about components. They are basically everywhere. So all you do in React is you write a lot of different components. So you can imagine that your application is kind of like a constructor, which is built with Lego blocks, right? And everybody likes Lego, likes to play with them. So basically, coding in React is the same stuff as building Lego. It's really fun. But it's not just only about fun. This splitting your application encapsulated components gives you a lot of different perks, which are code reuse. It means that your components can be used across of your application. Debugging, so when you see some unexpected behavior, you might notice, you might see in which component the bug happening. The same stuff with testing, so you just write a test for your components and you cover your application. And the separation of concerns is really nice feature. So some of components are responsible for one feature, some of another, and it's really great. It makes user experience, developer experience nice, and you will be happy. Okay, so React is all about a component. What is a React component? So think of it as an instance that represents a part of user interface, right? But there are some stuff which is valid for only React components. Those are state, properties, and lifecycle methods. State is just an object which tells your component how to behave and be rendered under different conditions. And it is kind of the internal part of the component which is not shared outside of the component. Properties is a data which is passed to your component from outside, from another component. And by telling data, I mean like anything. It can be numbers, I don't know, strings, arrays, other functions, or even different React components. And lifecycle methods, they're quite important. Those are internal functions which are executed during the lifecycle of the component. For example, the render, which is executed anytime something is changing in the state of the component. Component will mount, did mount. I think the names are quite obvious here. Okay, so I think it's enough talking, and let's have an example of real component. I hope you can see the code here. Can you? Sure. Okay, so let's have a look at HTML first. Please notice that we have React connected to our HTML page. And also we've got a div with ID container, which is going to be a container for our application. So the React will be rendered inside of this container. And that's it. We don't have HTML anymore, so we can get rid of it. We are going to use ES6 classes for writing our React code. So we've added ES6 and Babel transpiler to our JavaScript. Let's go here. Here we can see the first component in our counter. It's a wrapper. So it's just a function which accepts a div and a counter component. And when we execute the function which is called React DOM.render, we specify which component we want to render here. We specify which component we want to render, and we also specify the DOM element, real DOM element, where this component will be rendered, right? So as a result, we've got this awesome counter. I hope it works. Yeah, it does work because I checked it like millions of times. Okay, so let's check the code. So here is our counter, but first let's go to render function. It has a div, it has a couple of buttons, it has some spaces, don't worry about it, it's just spaces. It also has a span, which takes its value from its state, from the state.count, and it displays the count, the amount of count here. So what is state, right? This state.count. It is here in the constructor. We have an object which is this the state.count equals 0. And also we've got two methods which are increment and decrement. They're doing basically the same stuff. They are updating our state. So they're calling function setState on the count, and they update current count taken from the state and add something like +1. And the same thing is valid for decrement, but it is decreases, right? -1. Okay. So whenever this function setState is called, the render function is executing, and component is rendered fully, totally, everything inside of this component. And it also updates the state, so it is rendered with the new value in the state, right? Okay, so let's make our component, I don't know, with more wider functionality by adding some properties to it, right? So for example, we want to have it rendered not just from 0, but from number we want to specify. Let it be, I don't know, 10. And we are gonna go here and do like this. So for now, in state, we've got that count takes its initial value from properties. And properties are properties which are passed to this component. And now we've got that counter is rendered with 10, which is pretty cool. Also, there is such thing which is called default props. So as you notice, at first we didn't have. So okay, let's do like this. We'll remove everything from here, and it will be still working because we have an object which is called default props here, and it has initial number which is 0. So it is taken from here. Okay, the same thing is for difference. Let me just initial number equals 10. Equals 10, and difference, I don't know, let it be difference, let it be 5. Yeah, and yeah, because we need to change our code here. we want our increment and decrement function take not just this predefined one, but take its value from the props, from difference. And let's execute it. Yeah, it will work. Also, when I was talking about components, I told you that it is like isolated piece of software. So they are behaving independently one from another. So we can just duplicate this component, append it somewhere here, and yeah, we'll get 2 more components. And when we increase and decrease, only one changes. So they are all independent from one from another. Also, there is a cool thing. What if you want to render components not just static ones, but from some data? For example, we have an array of some numbers, and we want to render like 5 components from all of those numbers. We just need to map through those numbers, and we need to render this component. Counter. Initial number is going to be the number, and the difference is going to be difference. Tag number. Okay, let's close this here. Yeah, and now we have 5 different components which behave, all of them behave differently. Right? But when we have this example, rendering the components from some data, we've got some warning here. Let's try to execute it. Yeah, we've got a warning here. It says that each child in an array of iterators should have a unique key property. We'll come back to this warning later, but now all we need to do is just to specify that key equals some unique value. So we need to provide a key property which will be an unique for this set of components. It's going to be an index, and it will come from here. Number index. Right? Yeah, so let's try to execute it again. Yeah, now everything works as expected, but we don't have this warning. But we'll come back to importance of this warning later. Okay, so this is the example of React component. Let's get back to our presentation. Okay, so now we have an idea of what the React component is and how to combine them. And so let's recap our knowledge about how does browser builds its web page. So there is a thing inside the browser which is called the main thread, and it is in charge of different things like executing your JavaScript, creating DOM elements, rendering the layout. So he sounds really like a really cool guy, like this one. Yeah, but the problem is that there is only one thread inside of the browser, so he's kind of forever alone. So let's imagine that you've got a project which is built only by one developer. You're really happy to have him, right? And you still want him to perform good, to work hard, and to work quickly at some point in the time. And that's why you don't want to overload him with the work. And the same you don't want to do with main thread. You don't want to overload it with the work he does. And by talking about work, I'll explain later. So, so in browser, we've got the JavaScript. It's the place where you write your functions, where you execute them. Also, we've got an HTML and CSS. Yeah, those are ingredients for our web pages. And so DOM3 is an object of those HTML elements, and the combination of DOM3 and CSS is a render tree. And the render tree is rendered in our layout. And so the operation of repainting your render tree to browser is called reflow. Yes, so it is a process of painting the render tree. And it is kind of inexpensive operation because it combines inserting or removing DOM elements to the page, calculating the size of elements, modifying some content, maybe perform some animation. So it's a lot of work to do. That's why it is an expensive procedure. And there is a good practice to reduce the amount of free flows. It is actually not a new idea. A lot of different frameworks using it, but React has a nice way to operate your main thread and to reduce the amount of free flows the browser does. So React helps us with it. Let's figure out how he does it. Okay, so we are coming to using React's virtual DOM. Let's have a look at this example. It's going to be an example of initial rendering of the component. So we've specified the component we want to render inside of the React.dom render function. We also specified the container where our application will be rendered. And under the hood, React will create an element, React element. This is just a JavaScript object, which have such keys like type, which is going to be a React component, some properties which are passed to this component, and children, elements which are inside of this component. And let's imagine that our list component looks like this. It's going to be a div with some button, and it's going to render some item components from the state. This does state.item. Okay, so our initial web page looks like this. We've got a DOM, we've got an element with ID container here, and we've got an element list created by React, right? So after that, React will want to create an instance of this list. It will bind the context to this list, will add some state and properties. It will create the instance. After creating the instance, it would like to create the DOM element out of this instance. But he doesn't know what the hell is list is. So it will ask, what the hell is list? And it will get the response that it's just a div with some button and some items. Okay, I will create some elements for all of those things. And then I will create some instances for these things. And after I'll create some instances, I will try to create DOM elements out of these things. So he does know what the div is, and it will create a div element. Then inside of the div, which is a wrapper for those button and items, it will create instances for button and items he got. He does know what the button is, but he doesn't know what the item is. That's why he'll ask again, what the hell is item? And let's imagine that item is just also a div with some text content, okay? So it will create three div elements for each item. Then it will create an instances of those things. And as long as he knows that what the div is, because it's a valid DOM element, HTML element, it will create those things. But so at first we had like container, then we've got div, which wraps all of those things. And please notice that those things are not still added to the container. So it will be added only after every element inside of the children of the list will be transpiled to DOM analogs, and only after that they will be connected to container, and this one will cause the reflow. So the browser, the page will be updated with new data. And the same stuff is valid for when you, for example, click this button, and it changes some text inside of those divs, this one and this one. So second and third. The process will be repeated again. It will create also elements for lists. It will create for div, for button, and so on. And then it will just check the previous value, the previous instances with new ones. And whenever something is not changed, it will be ignored. So for example, if wrapper hasn't changed, button hasn't changed at all, and this item hasn't changed, this div, they will be skipped, just skipped. And when it sees that previous instance is different from this one, it will render it in the DOM. So the thing is that React figures out the small number of changes which are needed to make the DOM, which need to be made to the DOM. So it batches those changes together, and that's why it reduces the amount of reflows. So this technique is called a virtual DOM, and it is allow us to improve our front end by avoiding direct working with DOM. That's the whole thing. Okay. So now we have an idea of how to reduce the amount of reflows. Let's talk about how to make React to work even faster. Just a second. We've got to the first item, which is the usage of the key property. We had this in our example here. I hope you remember it. When we didn't have this key, we've got this warning. Sorry. Yeah, we've got this warning whenever we don't have key. It looks like this. So I'm gonna tell you the importance of using of this key property. So whenever React creates the elements from the components, the structure looks like this. So remember, we've got a list, it has a button, and there was an array of some items. All right? But whenever elements are transpiled to instances, this data is flattened. So it is no longer an array of some arrays, so it's not a complicated structure. It's going to be just a plain object with such keys as like 0 is button because it's the first element, then it's going to be first element because it's sibling, next sibling, but there are different instances of those items, like .0, .1, and .2. That's why they have additional instances. Okay, and let's have an example here. We've got a button, a reverse button, and we have some items like orange, grapes, and melon. And whenever we press this button, the order of those things change. So at first we had such structure as .0 is button, then there were oranges, grapes, and melons, and the next instances are the same button, melons, grapes, and oranges. So the order changed, but those indexes are the same because they are built based on the order of those elements in the array of children, right? So basically, it is try to compare oranges with melons. Grapes is grapes and melons is oranges. And of course, those things are different because orange is not melon, and so on. So it will think that those elements has changed, and it will render the DOM for them. Okay, but when we provide the key property, our names for keys inside of the object will look like this. So they will have some additional unique name, like .1 is orange, and it's orange, grapes, and melons, and so on. And whenever React will compare previous and next instances, it will notice that orange is here, and there is also an orange here. And it will compare those things together. So it will figure out that the only thing that actually changed is just the order of those elements in the DOM. So it will just change those two instead of rendering them. Actually, so this example, it's not really, so usage of key property in this example will not have any like boost in performance because there are only 3 elements here, right? But what if, for example, we've got, I don't know, a big structure of different React components and yeah, like thousands of elements, it might save a lot of time for rendering. So yeah, it is useful when you deal with complex DOM structures because it helps to match previous and current instances of different elements. Okay, let's have a look at next one, which is the usage of should component update. I think that the name for this is quite obvious. So it just checks whether the render function of the component should be executed or not. By default, this function returns true all the time, so render executes every time, but when we use it, it might not. Okay, so here what it accepts. It accepts next properties and next state, which were passed to the component, and it will just perform a quick check if this state.items is the same as next ones, and if they are the same, there is no need to render the component, so we'll return false. But if they're not, component will be rendered. But there is such problem. There is a problem with using should component update because it is connected with the way you update your data inside of the state of your component. It's quite tricky. So here is the first example of how can you update your data in the state. You've got a new item. You get the current items here, and then you just push the new item to the array of next items, and you set state there. So your items is next items. Okay, so in this case, the result for should component update will be always false. And you will never see the items which are new. Well, because you are returning the same array, and when you compare the same array to itself, it is always true, and that's why this thing will return false, right? Okay, so we don't want to use this case. Let's have a look at another case. The same thing, we've got a new item, and next items is this state.items with edit new items. That is a spread operator of ECMAScript 6. Okay, so we return the new array, right? And when we try to execute the comparison, the result will always be true because we've actually returned the new instance of the array. And remember that we've got comparison something like this. So whenever the new array is returned, it will always be oh my god. Whenever the new array is returned, so when you compare the one array to another array, it's always will be false. That's why it will be returned true. So the should component update method will be executed every time. What you can do is you can make a deep checking inside of your should component update, but it's probably not a good idea because the execution of this deep checking might take a longer time than the rendering method itself, and there won't be any boost in performance. So what should I do in this case? So we've got two different options and none of them are good for us. There is a solution to use immutable data. There is also a library from Facebook which is called immutable.js, and also there are different implementations of this like pattern. The main idea is when you've got something created, it can be never changed. So whenever something is changing, you just return the new instance of it. So you should check it out, the immutable data. It's really cool, and it will actually help you to perform those quick equal checks for your previous state and new one. And yeah, in this case, should component on date will work correctly, and you will save some time for rendering. Okay, so yeah. And we're going to our last example, which is usage of set state lower in a tree. So let's come back to our list here. So we've got a list, it's got a div, buttons, and some items in it. So whenever something is changing, some item has changed, right? And you are setting state on the level of your list component, everything is going to be rendered, right? So because those are the children of this list component. But if you set state on the level of these items, it will render only this particular item that has been changed. Okay, and the same thing is valid for Redux's connect function. I don't know if you're familiar with it. It might be trickier to use it in Redux the same way, because you might need to think about how to change the model, the processing of your data, but it is achievable. Yeah, okay, so let's sum up. We've got like 3 items here. So we should use key properties in order to help React to match previous and new instances. And we should use should component update and immutability to prevent a component from calling the unnecessary renders. It will save some amount of work. And we should use set state and or connect if you're using Redux lower in a tree, just in order to change the elements that have actually been changed. Yeah, okay. So I just want to tell you that this talk is based on the talk which were performed by Lynn Clark. It was on a React Europe conference. If I explain some examples really bad, you should check her talk, because she is amazing. She is explaining some technical stuff in the form of cartoons. It is really cool. I'll have a link here to her presentation. And also she is doing those code cartoons. She's explaining technical stuff with cool examples, and they're really awesome. So yeah, and one more thing I wanted to tell you is that it's all just JavaScript. And what I mean by that is that under the hood of every framework and library, there is our old language, which is called JavaScript. And I don't want you to become like some framework-specific developers, because I think that it is important to understand how things are working under the hood. Okay, so I think that's it. Dziękuję bardzo.